If a report takes too long to load, people just won't use it. So 5 to 10 seconds, yeah, that's pretty heavy. However, from our experience, with many cases, most issues are heavily reliant on data connection type and the data model, especially the data model. Today, we are diving into one of the most overlooked yet most critical aspects of Power BI, performance. We've all been there. You click on a report, and by the time it finally opens, you've lost focus. It doesn't matter how great your dashboards look or how advanced your calculations are. If a report takes too long to load, people just won't use it. Now, this directly impacts adoption, trust, and ultimately the decisions your business makes. So 5 to 10 seconds, yeah, that's still pretty heavy. More than 10 seconds, a bunch of votes for that. Okay, I can see that there's a lot of different experiences, but not many like really fast and snappy and like best practice experiences with performance. So I guess this is an evergreen topic. Yeah, most of you seems that you have like on average not too shabby, right? It seems that most of you know what you're doing, but let's see if we can give some tips to get even better results, right? To get in that upper echelons of performance where you're like really happy with how everything is responsive and like really having a good user experience with your users as well. But yeah, let's get serious now, right? So we want to go over the performance best practices, at least the ones that we found with our extensive work with clients, work best, and what we've learned so far. It should be really interesting. Now, in order to improve performance, we first need to understand a few key parts of the process, which are the source connection type and speed, and this is important, the type of the data model we use, and what we can do on the visualization layer to speed things up. Now, the visualization layer is maybe less important than the first two, but of course, we also need to then govern and analyze and optimize, right? And if we want to ensure this at scale, all of the parts are important, right? However, from our experience with many cases, most issues are heavily reliant on the first two, right? So the data connection type and the data model, especially the data model. So what we need to do is, of course, speed up both the connection, right, and the data model, right? So the source connection that we're pulling from, of course, the source itself is a huge part of this, but what we can control in Power BI is the connection and the data model. Okay, so first are the connection types, and they're quite different from each other in terms of performance. The fastest one, without any doubt, is import. You load the data once into Power BI and makes use of the Vertipack engine. It's optimized for tabular models. It's super fast, in-memory database, has excellent compression, and so on, right? And you have like full control, full access to like Power Query, to DAX. But there is, of course, a data limit and the limit of how many refreshes you can do, right? You cannot have real-time intelligence on import. Now, DirectQuery doesn't capture the benefits of Vertipack, and you need to optimize all those queries on the backend. And even with all the optimization, you cannot optimize it to perform like import. Now, I will just quote Marco Russo, who is an expert in the field. I'm sure pretty much everyone in Power BI will know who Marco Russo is, but he's the guy, one of the guys behind SQL BI, and these are his words verbatim, right? Import mode is 10 to 100 times faster than DirectQuery, even after optimizations. You cannot optimize DirectQuery to perform like import mode. It's like trying to make your daily commute car go hypersonic. Not happening, right? So these are his words, the top experts that are like spending full time on performance, on DAX, on all these intricacies, these are the worst. So DirectQuery will never be as fast as import, and it has other limitations in terms of transformations you can do, right, and so on. Then we also have live connection, typically to Azure or SQL analysis services. This used to be like the standard, especially for like bigger deployments. And on enterprise tabular databases, like almost as the same one as in Power BI, right? And those are typically fast, right? It's really scalable. But of course, there's some limitations on what you can do then from the Power BI side of things. You have to build the models in analysis services and so on. And last is the type of model that is more and more common, and it has been getting some quite improvements, and these are composite models, right? And those can actually combine different types like import and direct query, or even direct query, direct lake, right? So the data lakes and so on are becoming are getting really popular, right, these days. And you can make it to be really fast, right? It's really a flexible connection type. And you would, for instance, have like some of the tables, or the majority of one, on import, but then where you only require direct query on a specific table, you would use that one. And if the requirement is real-time data or like refreshes, this will almost always be preferable to direct query. So in terms of connection types, import mode is the fastest one for performance. Now let's move to the number one reason why your Power BI report is slow. And this is a messy data model, right? Data model is probably the most important thing to make sure that you handle it correctly. And this is an example of such a model, right? It's all tangled up. We have multiple fact tables, cross joins, tons of joins, bridge tables, then connecting different dimensions to facts and and to other facts. And this will inevitably lead to complex DAX formulas, many-to-many relationships, which are very, very expensive in terms of like drag on your performance, unused columns, DAX measures, and even tables, right? Bloating up everything. And naturally, this will be very, very slow. And this is a real life case of a data model. And the good news is this can be transformed into a proper data model. Even if you inherit such a model, it can be transformed. But yes, this will typically be the biggest drag on your performance. And whatever you do on the front end, whatever you do with the connection, if you have a wrong or completely garbage data model, you will not be able to have fast reports and a good experience in Power BI. So, and the key reasons for this kind of data models are as follows. So lack of proper data preparation and ETL, separated like fact tables and multiple of them. So you need to kind of do these joins and so on. Lookup tables instead of like proper hierarchies and dimensions, right? And including all possible columns instead of only required ones. So the requirement comes typically for business, right? You want to do a lot of different stuff, right? There's a lot of, and you want to give the full flexibility to all of your users, especially with larger deployments, right? You need your data model to be flexible to do all of this. But this is typically where it's really, really important that you do proper planning with the business users at the start before you start bloating your data model with things that in the end will never be used, right? And this can have really, really, really big impact on your performance. And of course, with large deployments and this kind of data models, this will also lead to unnecessarily complex row-level security, right? Which again can be a drag on your performance. And this forces you to use really complex DAX expressions and bridge tables and many-to-many tables, all the bad things that we mentioned before, right? So this kind of data modeling, we actually call data knitting, not data modeling, because you're just taking all these connections and strands between tables and just trying to make it work, which again, in the end, will just result in a big ball of mess. Now, the alternative is, of course, to look at some proper data models, right? And these are I'd say the more common ones, right? So either you use a flat table, you build a star schema, a snowflake, which is basically a star schema expanded with some dimensions, and this can work. And of course, the messy data model. Now, the winner in Power BI is, let's hear it, drum roll, it's the star schema, right? It's the tried and true best data model. And yes, flat model can be faster with extremely simple queries, right? There's been some debates in this regard as well. And here's a link to the article that actually compares the two data models, so you can check it out in your own time. But as soon as the queries increase in complexity, the benefits of the flat data model fade away very quickly. If the query is not pure storage engine query, the star schema model performs much better in 99.9% of cases. When it comes to retrieving values from the slicers, the flat model is extremely slow. The important takeaway here is the following. When the flat table is better, it is not that much better, right? But when it's worse, it's far worse. And in all practical deployments so far that we've seen, the star schema was clearly the best choice in Power BI. But yes, this means that you have to prepare this lean data model, which is the star schema. And these are like the important parts of it, right? So the star schema, we have one-to-many relationships from the dimensions tables to our central fact table. We only have the necessary elements, and this enables us to have simple DAX and have fast data modeling and Power BI reports experience. And this is a real case exactly down from that messy data model that we saw before, right, to 8 tables. Okay, so if you want to have performance reports, there is no avoiding this. You need to do your data and model preparation. You need to append different fact tables into one main fact table, transform your hierarchies and attributes into a single dimensions, and filter out any columns that will not be used. Any columns should ideally be filtered out. Now, you can do this either in Power Query or ideally even at the data source, right? And for some specific, of course, measures and calculations, you can do it in DAX, right, later on. Now, this would be the typical example of a star schema, right? So we have a central fact table. You can include measures in the fact table and hide all the rest, right? Or you can even create a separate table just for the measures, and that will also be a good way, right? But you can then structure it in folders and so on. We want to hide all the implicit measures, right? So implicit values, or even like disable them, and I'll show you how to do this later, and use only explicit measures. Now, we also hide the foreign keys, and we want them to be on the integers, right? So number type columns should be the ones to use for these relationships. And if possible, should be as short as possible. Again, we hide them, and we also want to reduce granularity here. On the dimensions, again, we hide the foreign keys, and we only display and use visible and necessary columns by which we will filter the rest. In the calendar table, we also, of course, want, like, ideally, we want to have a calendar table. And here, it's actually preferable to use a date-time column and mark it as such. And I'll also explain this. And we want to avoid as many calculated columns as possible. And the last thing is, of course, yes, one-to-many relationships from the dimensions that are small, short, and narrow, and we will filter the main fact table where all our data and metrics will reside. Now, I'll show you also one thing that is important here and can result in really bad performance if we keep this unchecked. For some reason in Power BI, if you have a calendar or date table, date field, Power BI will automatically generate calendar tables behind each date field that it will find, right? Shipping dates, sales dates, and so on, order dates, all of those will generate individual calendar calculated tables. And this can really slow down the entire data model or even crash the experience for like many users. So the first thing we actually recommend in Power BI is to go into File, Options and Settings. And here we want to first turn this auto time intelligence. So we go to data load, we turn this off. This will be on by default. And it's good if you have a simple file and you just have one date field and it will generate some calendar for you out of the date field. So you can basically use like the typical time intelligence and year, month, and quarter fields. But this ideally should really on all your models should be turned off. And even in the current file, right, we need to just turn this off. And it's best to then mark your primary calendar table as a dates table and mark the primary date column for which you will do time intelligence from. This ensures that you have like just one proper calendar table and you're not bloating your data model unnecessarily. Okay, so let's return to the presentation. Now, the next thing that is really important that we want to do is we want to push calculations upstream. And this is an excerpt from Matthew Roche's maxim of data transformation. Those of you who don't know who Matthew Roche is, he's a member of Microsoft's CAT team, and he's been in data longer than I think longer even than I'm on this planet. So he's kind of a let's say authority in this regard, right? And his maxim states as such: data should be transformed as far upstream as possible and as far downstream as necessary. Now, when you're deciding whether to use DAX or Power Query, whether you should do it in DAX or Power Query or at the source, right? Note this, right? Performing data transformation in Power Query ensures that when your data is refreshed, the data is loaded into the data model in the shape it needs to be in. Your report logic will be simplified and thus easier to maintain and will likely perform better because that Vertipack engine will need to do less work as users interact with the report. If you need the data transformation logic that depends on the context of the current user interacting with the report, things like slicers and cross-filtering, this is the perfect job for DAX measure, because Power Query doesn't have access to the report context, right? So implementing this logic farther downstream in DAX makes sense because it's necessary. Okay, so what then to do with like a calendar dimension, right? Should you generate it in DAX or Power Query? Typically, it would be best to do it in Power Query or even at the source, right? Much better than having it in DAX, as it then won't consume time to evaluate on every interaction. Okay, so from a performance perspective, it's always better to perform a given data transformation as few times as possible. It's best to not need to transform that data at all, as data transformation is a costly operation. But sometimes you cannot go all the way, right, to the source, but just do it as far as you can. Now, let me show you an example where you can actually check if the query itself is folding back to the native SQL query source, for instance, in Power Query. If we go into Power BI and in transform data, we can actually check if we can see the native query, which means that the query is folding, right? So here I'm connected to a SQL data source. And on the steps for this particular table, right, I can actually right-click on the steps. And if I see view native query, this is a good indication that this will actually fold the query back to the source, right? So we're doing we're reusing the fast SQL query that can be generated out of this. Now, some transformations will actually break this. So for instance, if I change this column into a different type, and I try to view native query, you'll see that I actually cannot see this query anymore, right? So it might be an indication that the query folding is not happening anymore, right? It's not necessary, but this is a good indication, right? I won't go into too much details about this, but this is a quick way how you can see if you're actually leveraging the speed of native SQL queries in your tables. Next is row level security, right? This can also be a performance killer. And in practice, we see that some of the rules are important to follow. And again, as before, star schema is a must for efficiency, right? If you want to have a fast and efficient row level security application, you should use the star schema data model. You should simplify rules, right? So no lookups, no joins, apply only to dimensions if possible. Use the user principal name instead of hard-coded names for consistent user identification. Don't create many redundant roles with similar logic. Don't rely on bidirectional relationships for filtering. But instead use like security groups for large deployments, right? And this can be then added and so on. There's also, of course, an option to consider alternative designs, right? Where you actually split the data model and reports for different audiences and publish to separate workspaces. Now, important here is that you should always test the rules using view as role during deployment, and of course, optimize the model first. So in Power BI, right, if you just want to see how a certain role is used, you can actually go to the modeling side, and here you can just use view as and then select the role that you create for your row level security, right? And then you can also test it. We'll see later on just how to do that as well. Okay, and if the row level security becomes too complex to maintain or slows down your reports noticeably, maybe yes, this alternative design is an approach that you can use, right? To rethink the model architecture or user segmentation. I know this might come as a bit of a surprise, right? But sometimes just using separate reports with workspace level access control is more scalable than having like one report for all users and then applying this row level security across the board, and it will inevitably be slow, right? So sometimes it's better just to publish for that direct level of access for that user group. So to recap, how to speed up the most important part of the puzzle for performance. First, choose the right connection. Next, of course, do your data prep. Implement a star schema data model, which is efficient, which Power BI is optimized for. Push the calculations upstream and simplify row level security, right? Avoid some overcomplicated roles and so on.